first a few words about the project. Some students have been sending me email asking about the detailed requirements, like the format of the student IDs, format of the course code, and credits, etc. So anything that's not specified in the requirements, you can judge with your common sense and make your own decision. So think of the requirements as a high-level document from the client. The client wants a course registration system. He doesn't care about the low-level details. As long as this system can allow students to register courses and do all the functionalities specified in the document, the details are not important. So just use your common sense. Okay, so software development processes. We discussed waterfall process, which is a very traditional, a conventional process where you start from requirements to analysis and design to coding, testing, and maintenance in a linear fashion. So at every stage, you produce a document. After requirements, you produce the requirement specification document. After analysis and design, you produce a design document, and so on. So you have clear milestones at each stage. This makes the process visible, which means that you know how much you have progressed for your project. So you can check milestones along the way. So it's a one-way process until the end. When you get to maintenance, you can go back to either requirement or to analysis, or to coding, or to testing. If you're just fixing a few minor bugs, you just go back to coding and testing. If you're adding a module, new functionality, then you go back to perhaps to design or to requirements. So this is at the maintenance stage. Before maintenance, before delivery of the product, it's a one-way linear flow. So this is a very rigid process. It's only applicable when requirements are well understood and unlikely to change, which is rarely the case for real projects. So the pro is that it imposes discipline, enforces standards, and makes the process predictable. Cons are that it assumes a linear development process. Linear means that it flows one way, and because you don't have any intermediate deliveries, that is, the whole development process is not visible to the client. It's visible to the developers, but clients only see the final product, which makes the process risky because you don't have feedback until the end. So the prototyping tries to fix that. It tries to give the client a very rough prototype very early in the process. So you build a prototype, you give it to the client for evaluation, refine it, and go back to perhaps review the second generation prototype, and etc. So this is similar to code and fix process, but has discipline and produces required artifacts. That is, you do have intermediate deliveries. It's useful when requirements are vague or unknown, since it allows exploration of user interface and functionality. So you can perhaps just build a mock-up of the user interface with nothing really behind it to show the user how the UI works. And based on user feedback, you can refine your prototype and what to do with the final prototype. The the correct approach is to throw away the prototype and restart the development. The prototype is only for clarifying the requirements at early stage. But oftentimes people do evolve the prototype towards a final product. So the pro are that requirements can be explored early and get a clear understanding of the system functionality, because many times clients can't really tell you what they want, but if you give them something, they'll tell you if it's what they want. So that's why prototypes can be helpful in the requirements stage. You can explore different solutions with a higher chance of finding the right solution. You give the client several alternatives and ask him which one he likes most. So it's not really a complete software development process. So it's used in conjunction with another software development process. That is, after prototyping, perhaps you go to a waterfall process after you get all the requirements using the prototypes, or some other process. So the process is not visible since few artifacts are produced. Documentation is often sparse or completely absent. That is, the artifacts are the prototypes, right? So documentation is not emphasized in this process, unlike in the waterfall process. The final product is not a complete system, but may be treated as such by the client. This product here has this quote around it. It means that the prototype looks like a product, and clients, if they like it, perhaps you'll have to evolve it into the final product. But if you do that, then it's poorly structured and hard to maintain. So it's advisable to throw away the prototype and start from scratch when developing the final delivered product. So phased software development process is when you plan for change. That is, you accept the fact that you cannot have hard, unchanged software requirements at the beginning. So then you just plan for change. So you develop a release and give it to the users, and let the users use it. Then, based on feedback, you give another release, and then another release, and so on. So this is very commonly used for open source projects, where you release periodic updates to the product and let the users download the product. And also, this is used for, say, web browsers. Firefox, they release a update every half a year also. You need to design the system so that it can be delivered in pieces, enabling the users to have some functionality to use it while the other pieces are being developed. There are two types of phased processes. One is incremental, one is iterative. So incremental is when you deliver a partial system as part of a release, but full functionality. So here's the animation, something wrong. Okay, hold on. Partial system. Okay, something wrong with the animation. So anyway, so you deliver part of the functionality first, say the blue part, and then for the first release, and then in the second release you add a yellow part. That's good. And finally you add the red part. So every time you deliver a partial system, but this part works fully. This part completely works. Iterative development is when you deliver the full system at the beginning, but perhaps only with raw functionality. So it can do everything it's designed to do, but perhaps the UI is very rough, or you don't have a very fancy user interface, etc. So the difference is that for incremental development, perhaps you only deliver the billing system at the first release, and then second release you deliver the registration system, etc. But for iterative development, you deliver the whole system, including billing, registration, etc., in the whole package. But each system may only contain the basic functionalities, and then in the next release you add more enhanced functionalities for each subsystem. So many organizations use a combination of iterative and incremental. So I think for say the web browser example, I think it's an iterative development, because every release of the web browser you can do everything, right? But every new release enhances, makes it better, right? For incremental development, I can't think of any example of incremental development. So for most commercial software, they're using iterative. So so the pros are that it promotes modularity. So the software is well structured, robust, and maintainable, because it forces you to build your system in modules. So especially if object-oriented development process is used, so objects especially are useful for building modular software. You can build modular software with non-object-oriented development. But if you use OO, the objects serves as a natural units for encapsulation for modules. So reduce the risk of project failure, because risk is confined to small pieces of the system. So you may fail in one piece of the system, but you can still deliver the rest. So highest priority pieces are delivered first, and so are the most tested pieces, so that you can prioritize the modules, and for the most essential functionalities you deliver it and test it heavily, and perhaps for the less essential parts you can put it into a later release and deliver it later. So allows early training and feedback, so users can be trained and provide real use feedback to the developers on early releases of the system. So create new markets early, particularly for functionality that's never been offered. That is especially for, say, games market. The time to market is very important. If you deliver a product, say 4 months ahead of your competitor, even if your product is very rudimentary, it may not have a lot of fancy features, but it's a new thing in the market, then perhaps you gain very good market opportunities compared to someone who delivers their product very late but with full features, right? So sometimes you need to beat your competitors and sacrifice some features. Allows frequent releases so that you can fix bugs globally and frequently. So you have this global population of users who are testing your product really for you, instead of just your own testers in the organization. So allows appropriate expertise to be applied, so that development team can focus on different areas of expertise with each release. So because you're adding new things at each release, so you can shift your focus along the way to focus on different parts of the system. So So cons are that the system pieces need to be relatively small. Because if you want to do frequent releases, each release is very incremental, right? So you add a little bit every time and do a minor release, and eventually after say 5 or 6 minor releases, you do a major release. You need to kind of cut up the requirements into small pieces and give to the user one piece at a time. So sometimes it can be hard to cut up the requirements this way. So maybe hard to identify common facilities needed by all pieces. That is, common facilities means that the underlying services used by your application, perhaps say messaging middleware is one facility, perhaps used by all application components or modules. So if you do this phased process, then perhaps we need to add a new piece. Then you find out you need to add a new facility. That is a new middleware mechanism or a new operating system mechanism. So then you need to add the facilities underneath the application. So you cannot really identify all the common facilities at the beginning because you don't have all the functionalities at the beginning. So agile software development process is a type of phased incremental approach. That is, you add a little bit, a little piece at any one time, gradually, but the focus, the major goal is responsiveness to change. That is, you involve the client very early and continuously throughout the process. So this is in contrast with the waterfall process, where the clients are only involved at the beginning and at the end of the process. But in Agile, you actually invite some clients to come over to the software organization and sit with you throughout the whole development process. So extreme programming is a type of agile or process where you first do some requirements and analysis to determine features needed, estimate time and cost for each feature, and client selects features to be included in each iteration because it's incremental. So in each release, you specify things to be put into the release. And during implementation, you do it one iteration at a time. So that is one release at a time. Each iteration is called a build. You break the development iteration into tasks, and for each task, you design test cases and implement using pair programming and integrate into current project. So this is so-called test-driven development. That is, when you design a software module, you design a test at the same time. That is, so for example, if you're developing a module for sorting an array of numbers, traditionally you design the module and then you run some test cases. But for extreme programming, you design the module before the module is even developed. You design test cases for it, and while you're developing, you continuously test the module. So it's called test-driven development. So it's implemented with pair programming, which means that a developer works with a tester as a pair, and they work concurrently when developing a particular module. And when this module is done, it's finished and tested, you integrate it into the current project, and then you pick up the next task, that is the next module to develop. So tasks can be carried out in parallel with many different pairs of developers and testers. So So major emphasis is in this part. That is, for each task, you design test cases, implement with pair programming, and integrate into final product. So the requirements analysis are very quick. They're not the focus of this process. The idea is that you get some rough requirements very quickly, very early in the process, and then you just dive into coding almost immediately. And as you're developing, as you're doing all the iterations, because you have close client interaction, you can get immediate feedback, and then continue development taking into account the feedback. So it's called agile. Agile means that you move very quickly. You can turn your direction very quickly. So extreme programming has only been successful for small-scale software projects when the client's requirements are vague. So because the requirements are vague, you cannot get a document from the client at the beginning, like what I give you for the course registration system. So therefore, you actually invite a client to come sit with the developers throughout the process to continuously ask the client, is this what you want, right? Does this work or not? If not, you immediately modify your requirements and for the next iteration. So, but it's successful for only for small scale projects because it's some people have criticized this process as more like hacking, where you just requirements are not emphasized and you just go into coding too quickly. It turns out this process actually works for certain small projects, but it's not advisable for large projects to adopt this process because it can get chaotic in the development, during development. So spiral software development process is when you you combine waterfall and prototyping and add additional element called risk analysis, highlighted in red. So, okay, you start from planning, where you analyze, determine objectives and constraints, and then you do risk analysis, which means that you identify all the possible project risks, and then make a go, no-go decision. If the risks seem too great, that is, your chance of success is too small, then you make a no-go decision, you abandon the project. Otherwise, if the risks seem acceptable, and then you make a go decision, you keep on developing the system. And then, in the engineering part, you do analysis, design, implementation. So for this little quadrant engineering part, it's really like a waterfall process. You do the traditional stages, and then you give the client the engineering result for feedback, for evaluation. So this is kind of like the prototyping process. So this is why we call the spiral as combination of waterfall and prototyping. So, and then you do some replanning based on a client evaluation. And then you do risk analysis again, and to make a go, no-go decision. And as we go around the spiral, you're gradually going. A spiral is when you go around, but then you go up, right? You don't stay in on the same plane. So as you go around the spiral, more and more complete versions of the software are built, and emphasis of the phases changes. You gradually shift emphasis from planning more and more to engineering as you go near the outer edges of the spiral. So eventually, the result is the final completed system. So we mentioned risk analysis. What are risks? Risks are anything that can go wrong, that is endanger success in a project. There can be technical risks where are you building the right system? That is, are you building the system that the client eventually want? System architecture. Did you pick the right architecture for your system? That is, if you want your system to scale up to millions of users, then you better design some load balancing architecture to spread up the load into perhaps a farm of server machines. If you have a central machine architecture with a single computer, you can't possibly hope to scale it up to millions of users. So you need to design your architecture to achieve your eventual goals. Of course, for your course registration system, you can have a single server because you only have, say, 2 users for your system, right? But for, say, the real registration system at SKUST, you can imagine they have a load balancing component with many servers. New technologies. So if you're using a new, say, Microsoft.NET technology and none of the developers are familiar with it, then it's a technical risk. Of course, performance. Can your system achieve the response time, the throughput required for a certain number of users? And there are non-technical risks. That is, do the people have the right expertise? Are they competent developers? Do they need training? So if they do, you need to take into account the training costs and time. And tight schedule. Is there room for mistake? Can you throw away part of the system in the middle of the project and redo it in the face of a tight schedule? And timely approvals. So approvals from client, can you get them in time? So if you need to modify some requirements and you seek client approval, do they take a month to get back to you, or 1 day? So all these are risks. So how to deal with risks? So you need management procedures. First is to avoid risks. That is, replan or change the requirements to avoid the risk. If the project requirements are too ambitious, perhaps you need to scale it down and confine the risks, confine the scope of the risk so that it affects only a small part of the project. So, for example, if you're using new technologies, perhaps you just use it for the UI. Then for the middleware and for the database, you use the more traditional technologies. So you confine the risks and mitigate the risk. That is, try to control the risk. Try out the risk to see if it occurs or not. If it occurs, then we can learn how to deal with it, avoid it, or confine it. Monitor the risk. Be on the lookout for it. That is, always monitor, and if a risk occurs, assess its severity and try to deal with it. So the greatest danger is project killer risk. That is, most risks are small. They can be overcome easily. But if you have a fatal risk that can kill your project, then you need to perhaps make a no-go decision, abandon the project to avoid wasting more money on it. It happens. So for some projects, after millions of dollars spent on it, it's abandoned because it's determined that if you keep on developing, it'll cost many more times more money. So the goal is to prioritize and deal with biggest risks as early as possible. That's why you need the spiral process, where you do a very early risk analysis in the process, and you continuously do risk analysis as you go around the spiral. So the pros are that it combines waterfall, prototyping, and phased. So the waterfall part is in the engineering quadrant, where you do analysis, design, implementation. You do a little waterfall in the engineering part, and then you go to client evaluation and risk analysis, etc. It's like a prototyping process because you have client evaluation in the middle. So you develop something and give the client for evaluation. So it also has elements of the phased process because you're developing the system incrementally, right? At every circle around the spiral, you're adding a new piece to the system or enhancing existing pieces. So risk approach reduces their problems. That is, the risk analysis is a unique feature to spiral process. None of the previous processes have this part. So by explicitly identifying risks, you can try to avoid, mitigate, or somehow deal with the risks. Focus early attention on options involving reuse. That is reuse because you have this incremental development, so you can have a more modular development, so you can reuse modules. Focus on early elimination of errors and weak solutions because you have this client evaluation early. Relates objectives to product development. That is planning and client evaluation. That is because you have client evaluation and then you do planning after evaluation, taking into account the client feedback. You can continuously assess your objectives. How easy is it to use? How reliable it is, based on feedback from the client. So you can these objectives can be integrated into the development process from start to the end, and helps to answer how much is enough question in resource allocation. That is because you're doing incremental planning, engineering, and evaluation. You know how much you have progressed along the way, so you can more accurately assess the resources required. Resources including money, time, and personnel. Helps prepare for evolution of the system. That is, it's a very natural fit for evolution or maintenance because you have this iterative incremental approach. Think of maintenance of just adding another spiral on top of the existing spiral. So the cons are that it's more appropriate for internal rather than a contract development. Why? Because for contract development, you need to sign a contract. Therefore, the client says, this is what I want, 1, 2, 3, 4. And then if you deliver these things, I'll pay you, right? But for the spiral process, you are involving the client continuously in the procedure. Perhaps the requirements are not fixed very early. So it is easy to get client approval if it's an internal project within the company. So, and based on client evaluation and feedback, you do replanning. But if it's a contract project, the client is external and a commercial contract is involved, then the client evaluation and replanning gets difficult. You need to get client approval, and that approval may not come easily. So relies on expertise in risk assessment. So how to assess, prioritize the risks. Which risk is a project killer risk, which one is a minor risk. So you need to have someone who is experienced in that. Needs more elaboration of the different steps in a cycle. That is for each step in a cycle is once around the spiral. For each step, you need to elaborate. That is, this spiral. This spiral shape is only a template, a high-level abstract framework where you can. But for your project, you need to elaborate each step into a more concrete process. Perhaps refine the engineering part with waterfall-like process. So greatest risk you have to deal with for your course project, one, not knowing how to work together as a team. So this can be a risk because some people just don't get along, right? So two, not knowing how to use Visual Basic. I think that's a minor risk. Your UST students, you can learn Visual Basic quickly. So not knowing how to use Microsoft Access, falling asleep during the lecture. Okay, so not knowing the exact requirements for the system. So that can be a risk. So you need to interact with the client, that is me, if something is unclear. Not having enough time to finish each activity. This is always a risk. So how to mitigate this risk? You need to work hard early instead of pushing everything to the end. So we talked about many processes, but software development is not an exact science, right? You cannot. It's not really a cookbook where you can look at a book and do 1, 2, 3, 4. Really, you need to customize the processes to your specific project, perhaps by combining different processes, different features of different processes. So here's one real-life example. Build a budget control system for a small, high-tech software consulting company that will monitor whether the financial transactions involved in their various projects are proceeding according to the original budgets, and to take corrective actions early if not on track. So think of a software company. You are developing software for external clients. You sign many contracts and many projects are ongoing concurrently. And each project, you get some money from the client, and you're spending the money on equipment, on personnel, on training. And you need to make sure that each project is on schedule and on budget. So that is the job of the budget control system. So you can have a clear view of the progress and the budget consumption of each project within the company. So it is a small company, around 30 persons. So the scenario is that the budget control activity needs to be customized to particular activities of the organization. So budget control is related to other administrative activities like payroll processing, income and expense monitoring, because what's the budget used for? Budget is used for payroll, to pay the engineers, and used for buying equipment, so income and expense monitoring. So all of these are different systems. A payroll system is processing payroll, and monitoring expense system is monitoring the expense. So the budget control system needs to interact with the other systems. So unlike these, budget control system is based on objective data, such as time and cost, and on subjective data, such as estimates of the value of the work in progress. So unlike, say, payroll processing, you pay an engineer $20,000 per month. So you pay this amount every month, and that's very predictable. But for budget control system, you're trying to control the budget of the ongoing project. How far has the project gone along after 6 months, and how much money is needed in the future? That's a very subjective metric. You need to, it's not as precise as payroll, right? So it's more difficult. And now staff may be involved in several projects at the same time. because it's a software organization, you may be working on different projects from different clients at the same time. So no log is kept about the contribution to each project. It's hard to estimate work in progress costs for each project. So, for example, if an engineer is an expert in user interface design, perhaps he's involved in designing user interface for 5 projects at the same time. So, how much time did he devote to project A versus project B? So that is very hard to determine. So this just adds to the subjectiveness of the budget control system. So that's the problem. That's the challenge. Now, what really happened in real life? So initially, first you do some initial assessment of the project. So the current administrative system is not suitable for providing all the data required for budget control, since the required data is either missing or in the wrong format. So you have a legacy system. Now you're building a new system to replace it. So the real problem is not budget control per se. It is understanding what it is with respect to this company. So a budget control system for company A, for this particular software company, may be very different from a budget control system for another company. So you need to understand the application domain to develop the system. So difficulties including an unusual nature of the activities of the company. It is unusual because it is different from, say, a construction company where you're building a house. It's very easy to assess the progress. But for software, it's often very fuzzy and very difficult to estimate progress. A lack of standard production rules for estimating value of work in progress. So perhaps lines of code could be a measure, but that's a very bad measure, right? So often need to reschedule and rebudget most activities as you go along. And personnel turnover, that is new people come in and old engineers leave, so you need to redo the budget. So therefore, due to all these problems, a precise statement of requirements is not possible. What does this tell you? It tells you that you cannot use waterfall, because waterfall is a one-way process. You must have precise requirements before everything else starts. So which of the following processes or combinations of processes would you use to develop the budget control system, and why? Code and fix, waterfall, prototyping phase, agile. Extreme programming is a type of agile process, or spiral. So any volunteers? Any? How about code and fix? First, we delete that because it's really a counterexample. It's a bad approach. Waterfall, as I said, is not suitable because you don't have precise requirements. Prototyping sounds reasonable, right? Phased, where you deliver the products incrementally and iteratively, that's also reasonable. Agile, perhaps okay. Spiral also sounds reasonable. So for this, this is not a single answer question. Really, what happened is really a combination of several approaches. So here's what actually happened in practice. So because the precise statement of the requirements could not be formulated after could only be formulated after some experience and trial and error, this rules out the waterfall process. So a team consisting of software engineers together with business administration background with business administration background, and the administrative manager was formed to capture and analyze requirements. So the administrative manager could be a secretary, could be someone who's using the budget control system daily, so who's very familiar with the application domain. So he's involved in the team to talk with the developers, informing the requirements. So the team decided to initially focus on organizational rather than technical aspects. That is, they're focusing on the application domain instead of deciding what server do I use, what programming language do I use. So these are technical aspects. So identify and classify information relevant to budget control. Its source of the information could be from the client or from documentation. Its relationship and likelihood of being changed. And then initially support it only predefined queries. That is, you cannot form ad hoc queries to the system like a SQL query. You can only select from, say, 5 predefined queries. It's a very rudimentary, very basic functionality. Define procedures for collecting budget control information. So you ask each staff member to record the time they spent on each project. So this is to address the situation where a developer may be working on several projects at the same time, and in order to track the progress on each project, you need to have information on the percentage of time he devotes to each project. So previously this information is not available, but now they ask the staff members to fill out this form to record the time, perhaps weekly. And data from the administrative system was duplicated for the budget control system. For example, the salary level of each engineer. So then they spent 2 months to understand the budget control process to a stage where something could be implemented. Before you even touch the code, you'd spend 2 months in understanding the requirements. The first prototype is a simple spreadsheet, Microsoft Excel. That was manually filled in, set up in half a day, and provided unlimited querying capabilities. Then you operate the prototype for 4 months, during which time it was utilized to understand the problems of budget control and design solutions that would yield better support tools. That is, you let the users use the system for 4 months. It's a very user-friendly system because it's a Microsoft Excel spreadsheet. The user needs to fill in each cell himself. So instead of a nice user interface. So this is a very rough prototype. So once the procedures and risks of budget control system were better understood, a second prototype was built that supported higher level querying facilities. That is more user-friendly queries instead of Excel queries, and flexible data formats and simple computation. That is, you can do some simple statistics on the data. So second prototype was using high-level development tools like Visual Basic and Crystal reports to create reports and a database to store the data instead of using a spreadsheet. So this is a more refined prototype, more user-friendly. Eventually, it was decided to integrate the budget control system into the administrative system. So the existing administrative information system ran on a central computer, and the new budget controls prototype ran on a PC. So how do you integrate these two together? They wrote a batch translator to allow the administrative system to supply partial information to the budget control system, like the staff salary levels. and part of the prototype budget control system was reused since efficiency was not the major issue. So they had the legacy budget control system, but it doesn't fulfill their requirements. However, some parts of it can be reused instead of developed from scratch. So why did this approach work in this case? So this process is really has elements of prototyping, because you're delivering 2 prototypes and eventually integrating this prototype with the administrative system into a more complete system. It has elements of a spiral process because you have risk analysis. Has elements of the incremental and iterative phased process, because you're adding new parts at each phase. So it's really a hybrid approach. So why did this approach work in this case? First, because the system is not very large, and because the company is small, it's only 30 people. So there's not much information to deal with. You need to track 30 engineers essentially. So for a large company, you need to more rigorous, more formal process and more emphasis on requirements, and perhaps produce a more formal requirements document. So in this case, there's not even a formal requirements document during the process. So since the developers are also the client, because it's an in-house project, you're developing the budget control system for your own company to track your own expenses. So the clients are also the developers. So they need to use the system to input their time for each project, etc. So therefore, the understanding of the application domain was not a really big issue. Unlike when you're developing an application for unfamiliar domain, it could be an issue. But in this case, the application domain is easy to understand. So this very informal process worked in this case. So the point of this example is that you should not take the processes as golden rules. There is no golden rule. There is no single best process. You need to perhaps combine several processes and customize it for your particular project. Every project is different. So, best practices. What are best practices? That is experiences and knowledge you summarize from many years of development. What worked and what didn't work in practice. That's best practices. So you have software engineering books that document all the best practices you can buy. So incorporating best practices leads to good methodologies and tools for software engineering. So what is a practice? So a practice is a technique that is proven to be effective. So the most efficient way of doing something, not from a university professor, but from engineers who are developing products daily. So these are the best practices summarized from from many years of software development. First, abstraction and generality. That is, you will focus on important aspects and reuse software by doing abstraction and generality. That is, you will focus on the more general aspects and focus on the details later in the process. So which processes have this feature? Waterfall and spiral. So they have this abstraction that is, you start from a very abstract and then gradually refine it to a more concrete artifact. So, for example, in waterfall, you start from abstract requirements, you do some design that's more concrete, and then you do implementation that's even more concrete, etc. So, rigor and formality, that is, you have well-defined steps along the way. This allows us to repeat what we have done and to produce better quality software. So this is waterfall and spiral. They are both have both emphasis on rigor and formality. On the other extreme, the agile process is the least formal, least rigorous process. So agile is only suitable for small projects. So separation of concerns and modularity. So this is when you develop the system in modules. So this allows us to divide responsibilities and work to different people in the team, and to work on parts independently, so that you can integrate pieces, modules together later. So if you have well-defined interfaces. So this waterfall, spiral, and phased, they all have this separation of concerns, a modularity feature. So incremental development, so allows us to evolve to the desired solution. That is, you do stuff, do the development increment step by step. Each step you add some new stuff to it. So you first identify the most important subset of a functionality and give it to the client, and then you add bells and whistles later. So can evolve the system. Obviously, phased is a classic incremental process. Also prototyping, and also agile and spiral, they're all incremental development. Anticipation of change, that is, you prepare from day one to prepare to be ready for change in the future. So develop the software to be ready for maintenance in the future. So software can undergo many changes constantly to fix bugs, to add new features, etc. So oftentimes the maintenance cost for a piece of software can exceed the development cost by many times. So you need to anticipate change. So for prototyping, agile and spiral, they all have this anticipation of change feature. So because you are continuously interacting with the client, so especially for spiral, so it's very suitable for maintenance, because the maintenance stage is just one more circle around the spiral. So risk assessment, this is a unique feature of a spiral process, allows us to deal with project threatening issues first. So by identifying the most critical risks, you can focus your resources on the most important parts of the system, so to avoid project failure. So, and if you decide the risks are too great, then you cancel, abandon the project, make a go no-go decision. So to avoid wasting more money on a hopeless project. So that's a brief survey of the software development processes. Now, any questions? So this course perhaps is unlike many of other courses you take. It's a lot of experience and very fuzzy, so it's not a more precise course like algorithms, right? So you need to get used to it when you actually go out to be an engineer. Oftentimes, real-life projects are messy. Now we have discussed all the development processes. Now we discuss unified software development process. So this is a process that actually is a blend of features of many other processes. It's a very heavyweight process that is not used. It's not easily used, as you can see later. But it can be very effective for large-scale projects. So, unified process is also called UP. So it has 4 phases: inception, elaboration, construction, and transition. So you have workflows corresponding to waterfall, but it's not a waterfall process. Engineering workflows include requirements, analysis, design, implementation, and testing. So, as you can see, horizontal axis is the time axis. As you go from left to right, from inception to transition, you place more emphasis on requirements. So this lumpy shape indicates the level of effort, the amount of time and resources you put into this particular activity. Requirements, you do some requirements in the inception phase. You do a lot of requirements in the elaboration phase and a little bit requirements in the construction phase. For analysis, you do bulk of the analysis in the elaboration phase. Design, you do it in elaboration and construction. Implementation, you mainly do it in construction, but you also do it a little bit in the inception and the elaboration phases, perhaps to develop the prototype, and also some in the transition phase to fix some bugs. And testing, you're doing it really throughout the process, throughout the phases, except in the inception phase where you don't have anything to test. So you do a little bit everywhere. So as you can see, at any point in time, if you take a snapshot on the time axis, you can see you're doing all 5 activities all at the same time, but different emphasis at different time in the process, in the phase, different phases. So that's engineering workflow. Then you have management workflow. This is the job of the project manager, who is to oversee the entire progress of the project. So he does project management and software QA throughout the 4 phases. We'll discuss QA and project management at the very end of the course. So the process goes like this. You go from requirements and then eventually to testing to project management once, and then you go back and redo the requirements, analysis, design, and then go around another time, and then you do another time, and gradually you move from left to right. Eventually, at this point, this is a cycle from inception to transition, or one generation. So this is one when you deliver the one generation of the product. So each vertical path from requirements down to testing to project management is called one iteration. So you do many iterations and gradually move from left to right. So let's see the animation again. So first iteration, second iteration, and then third iteration. As you go along the iterations, it gets faster and faster. That is, the time is actually taking the shorter and shorter, and also your focus shifts. Your focus on the early iterations are mostly focusing on requirements, and then you gradually move to analysis and gradually move to implementation as you go to later iterations. So you can imagine if it's a waterfall process, you can think of it as how do you draw the diagram? Perhaps you have one block of requirements, one block of analysis, one block of design, and there's no overlap, right? That's waterfall. But here you have overlap, so that's not waterfall. So each cycle results in the release of the system. That may include source code, documentation, manuals, etc. So this process takes into account requirements changes. You do not need a fixed requirement at the beginning. So let's talk more detail about the different phases. For the inception phase, you determine the system's lifecycle objectives, establish feasibility to validate technical decisions and business requirements. Is it feasible to develop the system? Is it too ambitious or not? Create a business case, that is, show a quantifiable business benefit. So you're building a system, you're taking money from your client. You need to present a case for it. Why are the clients spending the money? Can the return on investment of the system justify the cost? Capture the essential requirements to set the system scope. That is, the client naturally would want you to develop a Swiss Army knife. They want everything. But you need to set the scope. You need to capture the essential requirements and cut off the unessential requirements. Identify critical and important risks and deal with them early. So this is element from spiral process. Then in the elaboration phase, you determine the lifecycle architecture. So elaboration is more of a computer science activity where you're trying to design the system to create an executable architecture baseline for the system. This is really a prototype. That is, you can execute it, but perhaps most of the functionality is empty. When you click a button, it does nothing, right? But it's a baseline. That is, it has all the major architecture pieces in it. Refine the risk assessment. That is, you have more deep understanding of the system. Now you can refine the risk assessment, and you can reprioritize the risks and have a deeper understanding of the risks, and deal with the second most important risks. So define the system quality attributes, design goals. If it's an airplane, a control system, perhaps safety and reliability are the most important. If it's a mobile game system, perhaps time to market is the most important goal. Capture 80% of the functional requirements. Not 100%, right? 80%. Create a construction phase plan. That is, for the next phase construction, you have a plan for it. This is a part of the project management. You set milestones for each timeline along the plan. Estimate needed resources, time, equipment, staff, and cost. Also part of the project management. Then in the construction phase, you build the initial operational system. You complete all requirements, analysis, and design. Evolve the architecture baseline into the final system. So notice here we say evolve. That is, this is not really a prototyping process where you're supposed to throw away the prototype. Here we building the baseline to have in mind that it'll be eventually evolved into the final system. So you are more careful in developing the baseline, architecture baseline. And finally, transition is when you release the product to the client. Correct defects and prepare the user site for the new software. Tailor the software to run on the user site. Tailor the software to their machines, to their operating systems, etc. modify the software, fix bugs, create user manuals and documentation, provide user consultancy, especially during the after early release. You need to have some dedicated engineers to consult as consultants. Conduct a post-project review. This is the job of the project manager to decide how well the project has gone, what lessons we have learned, and what went wrong, etc. So all the workflows are carried out during each phase, but with the focus changes. That is 4 phases: inception, elaboration, construction, and transition. At each phase, you carry out all 4 workflows. At each of the phases, you do a round from requirements to the analysis to design to implementation. Each one is a workflow step, and but gradually shifting focus at each phase to more initially focusing on requirements and later focusing more on implementation. So the unified process selects from the best practices of previous processes. So it's a hybrid process. Provide a generic process framework for software development. So it's a guideline that needs to be instantiated, specialized for specific application areas, organizations, competence levels, project sizes, etc. So it's a template, defines a set of activities and workflows. So to transform users' requirements into a software system, the workflows include engineering workflows, that is requirements analysis, design, implementation, testing, and management workflows. That includes software QA and project management. Define a set of models and artifacts range from abstract to concrete. That is, abstract is artifact is requirements document, for example. Concrete is the actual code. Allows component-based development. Software components are interconnected via well-defined interfaces because you're developing the system incrementally. It naturally fits a component-based development. You're adding one component, one module at a time. So component is really synonymous with module. So it's use case and risk driven. We'll discuss use cases later. A use case is, say, register for a course. That is a use case. Or select a course to teach. That's another use case. So it's use case driven and risk driven. So you analyze risks, assess risks in the process. Software architecture centric. That is, you develop a architecture baseline very early. This architecture baseline is a skeleton of the system. Then you gradually add flesh to the skeleton. It's like building a house. You build the architecture first, and then you gradually add the details. Iterative and incremental. So as you go along different iterations, you gradually add more details. So okay, so any questions on this process? So I think we'll go, the next step is use cases. So we'll discuss use cases next class. Okay, see you later.